Bienvenidos, Ushamdeed, and welcome to this NetAcad Introduction to Python course supplemental video tutorial. In this video tutorial, we're going to be tackling Lab 4.1.3.10, where we're going to be converting fuel consumption. And this lab, while listed as easy and indicating that it should take 10 to 15 minutes, is a little more difficult than easy, I believe, for a beginning learner. So we're going to be doing some conversion, and they're talking about the scenario here about a car's fuel consumption. In the United States, we're very familiar with miles per gallon. However, in Europe, they talk about the amount of fuel consumed per 100 kilometers. Right? So we talk about it in terms of miles per gallon, like your Toyota Prius gets 40 miles per each gallon of fuel that you put into the tank. In Europe, they show the amount of fuel consumed per 100 kilometers, right? And they also use liters as the fuel. And so our task is to write a pair of functions converting the liters per 100 kilometers into miles per gallon and vice versa. And you can see right here, the first function that we'll be working is liters per 100 kilometers to miles per gallon. And again, when we're given liters as the unit of measurement. So you can see the three invocations or calls to that function are going to be passing in 3.9 liters of fuel, 7.5 liters per fuel, liters of fuel, and 10 liters of fuel. Now, the reason that that's important, having worked through this, is that the first call to each function is sort of the inverse. You can see that when we pass in 3.9 liters of fuel, we're going to get 60 miles, right? And actually, what are we returning? We're going to be returning the miles divided by the number of gallons. And there's the 3.9 when we pass in 60.3. So it's a little way for us to check to make sure that it works in the reverse order. And then we've got different values that are going to be, for the second one, it's pretty close. And then to the third one, it's completely different. So we're going to go ahead and work through this. I'm going to talk about each step of the code and how I'm going to consolidate what we're using. And I'm actually going to talk about where consolidation might not be the best thing, where we're going to get way out here on the right-hand side, maybe one number that's going to be different. But I'm going to show you how to get it exact. And then I'm going to show you how consolidation could actually hurt you here. Now, this is going to be critical in terms of the, I shouldn't say the functions, in terms of the equations or the conversions that we're going to be doing. So let's go ahead and dive in here. And I've got everything in the Integrated Development Learning Environment, or IDLE, and we've created a new file called 4.1.3.10. And it says put your code here. So we'll pull that back. That was a cut and paste. And we're going to come into, wait, what did I do there? Let's go 1, 2, 3, 4. All right. So the first thing that we want to do in the liters to 100 kilometers to miles per gallon is we know we're going to have to do some conversion here, right? And the first thing we're going to want to convert, we're being passed in liters of fuel. So we can see right here that 1 American gallon is 3.78 liters. And so how could we figure out how many gallons we're getting based on the number of liters? Well, to do that, we would say the number of gallons is going to be the value that we're being passed, right? That positional parameter, liters, that here is a positional argument, a float, 3.9, is going to be passed in. We're going to deal with it in terms of liters. So 3.9 liters divided by the value that they gave us earlier, which is going to be 785,411. And yes, I do have the equation they gave us here, or I shouldn't say the equation, but the conversion they gave us here, 1 American gallon is 3.78541784 liters. If I get passed in 3.9 liters, I would divide that number of liters by the number of liters in a gallon to give me the total number of gallons, right? And so that's how I'm coming up with that equation. Again, they have it listed as easy, but this could be rather tricky when we're doing the conversions. Now, the next conversion we're going to do is, I think, probably the trickiest, because they're giving you some values, but they give you the values, I think it's in meters. Yeah. So again, if we want to know, if we're going to end up returning miles divided by gallons, right, for the miles per gallon, we're going to need to know how that would work, right? Or I should say liters to 100 kilometers to miles per gallon. So we're going to work with the miles value now, but you can see what they do here. They say 1 American mile is 1,609.344 meters, not kilometers. So kilo meaning 1,000 meters. So if I was going to do this in kilometers, which is what we're doing, I would say 1, 2, 3. I would move the decimal place over 3 places, right, to give you the sort of the 1.609344. But again, to get that value that we're looking for in terms of the kilometers per American mile, right? Oops, sorry, I didn't want to do that there. Let's get back in there. There we go. So the kilometers per American mile, let's pull the calculator up here. So if I was to use the calculator and I was to say, if we had 1,000 kilometers, or a kilo, right? Kilometer, a single kilometer is 1,000. If I divided that by 1609.344, make sure that's right there, 1609.344, right? We end up with this value here, right? So 0.6213711, and you can see it goes out quite a bit there, and it ends in 7344. And so dividing a kilometer, right, which is 1,000, by this meters value is going to give me close to the value that I need. But again, remember, we're talking about 100 kilometers. So I'm dealing with 1 kilometer right here, right? And dividing it by, and that kilometer being 1,000, dividing it by the number of meters that are in an American mile. And that's going to give me this value here. And I've got that value written down. And so let's come back over here. And so for the miles, we're dealing again with 100 kilometers, but I'm going to multiply that times 0.62. And this is what it would work out to, 0.62. Let me make sure I get this right here. 13711 922 37334. Excuse me. And so again, I'm basically putting the result here, because this is going to remain constant, right? So, because again, what I could have said was divided by 1.609, et cetera, 0.344, right? But instead of doing that, right, I'm consolidating it down into what the result would have been from dividing 1,000 by 1609.344. So that's going to be the value for miles. It's going to be 100 times 0.62. And then we've got the gallons is going to be the number of liters that were passed in divided by the number of liters in a gallon, so that we get the total number of gallons. And then finally, I'm simply going to return the miles divided by, and again, division, we're doing integer division, I should say floating point division here, and not floor division or integer division. So, and this should work, and we can test this right out of the gate. I'm going to pull this code back here, and instead of doing all of this, there's that keyword pass. What a great idea to put the keyword pass in here to check to see, is this going to return what I think it is? So let's hit F5. We'll say OK. And you can see that we end up with 60, 31, and 23, and 31, 62, all 4s and all 3s. Let's come over here and see 31, 62, all 4s at the end, all 3s at the end. And in investigating that, it looks pretty close, and it's spot on. So it's spot on. Now, where maybe we can't do conversion, right? And let me show you the first example of where conversion is going to cost us. Because you might be saying, well, hold on. If on this side you went ahead and you did the division of 1,000 by 1609.344, why don't you just do the multiplication as well? And what would that look like? Well, if I was to pull this back and say 62.137119, and again, that would be multiplying 0.62 by 100. Just move the decimal place, the decimal 2 places to the right. Let's take a look and see what we get here. And what we're going to find is that by hard coding the miles value in, take a look at the difference between the first, second, and third values we get returned. Now, you may say that's kind of ridiculous. I mean, you're out, to the gajillionth decimal place here, but based off what the activity is saying should be returned, if I try to put the number of miles and do all of the math to get it down to what it would be as a constant here, right? 62.137, we end up with that last decimal place sort of, and actually 31625. We just end up out another decimal place here, right? So it's not going to return exactly what the activity wants us to return. So that could be costly. So if I leave that there and then pull this back, and again, it's just going out to another decimal place, making it a little more, I guess you could argue, accurate, but it doesn't give us what the activity was going to give us, or what we were supposed to be giving in terms of what the activity is expecting. It gives us a result that's different than that. All right, so now, excuse me, if I was to pass in the number of miles, right? I think I may have said miles per gallon up here, but when we're returning miles divided by gallons, right? We're telling the number of miles per gallon. So now let's go ahead, and if we were to look at this here, if I pass in 60.3, right, it's going to be miles. And so what are the values that I'm going to need to go from miles per gallon to liters per 100 kilometers? Well, the first thing that we're going to need is, we know that if we were dealing up here with gallons and miles, down here we're going to need liters and kilometers. And so again, if I come back to the values that they gave us over here, we know that a liter, right? 1 liter, I'll use liters. We know that liters, excuse me, when we're talking about miles, is going to be 3.78. So it's at 3.785. It's the same value that we have up here. In fact, we can just simply pull this down and copy and paste, right? So if it's 60.3 miles, we know that we're going to set liters to 3.78 because, right, 3.784 liters is 1 gallon. And so we're passing in 60.3. We hard code liters to be equivalent to a single gallon, and then kilometers, what we're going to do, it's going to be the miles that gets passed in multiplied by, and so the value that I'm going to use here, it's interesting, and I'll pull the activity up because I actually referenced this activity when preparing to put this together, is there's a course in a lab where you have the number of kilometers and you're pulling some JSON data, and that data is being returned to you as a distance, right? But the distance is miles, and to get from the miles to the kilometers, we multiply by 1.61. Well, the 1.61 value, and let me see where that is at, is coming out of that value right there, but in meters, right? In meters. So let's pull the calculator up. So if I was to say 1609.344 meters, and if I wanted kilometers, if I was to divide that by, and what would it be? 100 kilometers? No, 1,000. Sorry, I want to divide by 1,000. 1609.344, and divide it by the kilometers is where I get the 1.609. So in the activity I showed you here, it's just rounded up, right? Because again, I mean, we're going out to like 10 decimal places. It's okay to round it off in that activity. In this activity, however, we're looking to match certain values. And so to do that, I would want to use this entire value, which is going to be 1.609344. But again, we're talking about, let's get that value in here, 1.609344. But this is not going to return, and I keep misspelling miles. This is not going to return what we think it's going to return in terms of the value for kilometers. So if I say return, we would return liters divided by kilometers. And what we're missing out is the 100. And watch, I'll run it right now, and we're going to get values that are not going to be correct, right? And you can see here, when we look at that, right, it's this kilometers value right here that's kind of throwing us off. And we're talking about 100 kilometers, not a single kilometer, which is what this would be doing for us, right? So what I would want to do is we're going to take the miles times the 1.609, and we're going to divide that by 100. Let's hit F5 and see what we get there. And here's where, when dividing by 100, and you could have seen if I moved the decimal place over 2, we ended up with 7467, 9916, and 3757, which I believe are the values that we're looking for. 3710, whoops, sorry, and 3710. And so those values work. Now, again, here, right, we have another opportunity to consolidate the code, but is it going to return exactly what the activity is looking for? And remember, if I divide, or what takes place first, right? And here's kind of where we get into the PEMDAS, right? Parentheses, exponentiation, multiplication is going to happen first, and then the division. And so really what this looks like, if I was to put it inside of parentheses, that's really what we're talking about. If I hit F5, we run it again, and we'll see that we end up with the exact same answers, because that's what we're doing first, right? And again, it's the order of operations with mathematics, and PEMDAS, P-E-M-D-A-S. Remember, that's kind of where this comes back into play. So what I can't do is divide this by 1,000 first, because we'd end up with incorrect answers. And let me show you what we would end up with. If I was to say, you know, dividing that by 1,000 first, we'd be shifting the decimal place, excuse me, to the left. And so it would be 1 decimal place. So I'd say 0.0, because it would be 1 decimal place, 2 decimal places. So now when I say F5 and I hit OK, you'll notice that we're going to be, it's not going to give us exactly what we're looking for. Where was it at? Yeah, it's right here. Yeah, so it's in this third spot here where we end up with a different value. And so again, to match what we're trying to match exactly, and it's just semantics here in terms of how we do this activity, we would do the division by 100, excuse me, because multiplication would be done first, right? So the miles that get passed in would be multiplied by 1.609, right? Keeping in mind that that's going to get us to kilometers, right? But we're talking about 100 kilometers. Okay, we're talking about 100 kilometers, liters per 100 kilometers again. So now we're going to divide the number of liters, which is 3.7854. And if I come back out here, that's 1 American gallon, right? And then convert to get my kilometers using the miles that were being passed times 1.609344 divided by 100 to get exactly what the activity is asking for, right? And again, we can get close if we were to consolidate here, but it's not going to be the same. And the same is true up here. I can consolidate that, but we go out one more decimal place. And so again, straightforward activity, but a little tricky with respect to doing some consolidation on your code in terms of the mathematical operations that are taking place and then matching it exactly to what the activity is asking for. So I would put this in sort of the easy to medium category in terms of an activity myself, especially for a beginning Python programmer. All right, well, that is going to wrap up this supplemental video tutorial on Lab 4.1.3.10, where we were converting fuel consumption, the liters per 100 kilometers, and then the miles per gallon, and we were doing the conversion in both directions. All right, thank you so much for watching. All the best to you in your studies and out there programming, and I hope to see you in the next video.